So hello, and welcome to my talk on containers. I'll be trying to show that containers aren't just so new. They've actually been around for a while. And I'll talk about some of my own experience working with them over the years. Although, hopefully it's education, at least. So my name is Tim Speed, and I've been developing software as a profession for roughly 14 years now. I have 10 years experience working with containers off and on, and about 13 with virtual machines. And more specifically today, I'm going to talk about containers, but a little bit about virtual machines. We're going to get into some of the software that makes containers contain, and a bit about why you might want to consider them. Sorry, I'm just going to rearranging these. Okay. So you might ask, what is a container? My definition is that a container applies a set of constraints that limit the capabilities of a process running within the host machine. So this can be used to protect that process from other processes through isolation, or create an environment that allows the process to be executed consistently across different host machines. So different people's laptops or like in a production environment. Containerization can sometimes be referred to as operating system level virtualization, which is kind of why I'm throwing in the virtual machines into this mix. So some examples of containerization software that you may or may not have heard of. You've probably heard of Docker by now. I mean, it's been around since 2014. I think they launched publicly. LXC is a big influence for me. It stands for Linux containers. That's from Canonical, the company that gives you Ubuntu Linux. And systemd nspawn was, I think, I don't want to say recently, it was at one point merged into the Linux kernel. And that is also a viable way to run containers. OpenVZ is, some of you older folks may have heard of that, or people who have experience buying or running virtual private servers in the past. OpenVZ is a popular way to kind of split up machines into smaller components and resell those for cheap. Another notable mention is Singularity, which seems to be focused on both performance and security for data science. I'll share the slides out after if anybody wants this stuff for reference, but yeah, there's a lot more of that stuff, but my talk isn't really about them, so let's move on. So how about VMs? So how do virtual machines relate to all of this? My definition of a virtual machine is that it is an isolated set of host machine resources with a separate BIOS and CMOS that enables another operating system to run within the host machine. Both VMs and containers can be used to isolate processes on a host machine in a similar way. But the key difference is that VMs also try to emulate a full machine, whereas containers are lighter weight, focusing on just the environment for the process. Some examples of VM software or virtual machine software that you might know of: VirtualBox, KVM, which is the standard go-to virtualizer in Linux, QEMU, which is short for QuickEMU, another popular like Linux VM / emulator for anything. I mean, you can virtualize whatever. And there may be many more, but I think in this case, you can even consider your favorite cloud provider as kind of a virtual machine platform. They run tons of servers, they split them up into virtual machines, and they give you those virtual machines when you hit their API or use their control software. Sorry, I just get confused with the button on this presentation window thing. So why even think about containing a process? You may be thinking such thoughts as everything works fine on my computer, or my software is super secure, it's not made by Microsoft. But the reality is different. You don't deploy to your MacBook, and there are probably other processes on a machine which operate, at least to some extent, out of your control. And this is the case even in production environments. So some general reasons for containerization is so isolation, number one, meaning that you can work to protect your machine from the process itself or the users using that process, or you can protect the process itself from other processes in the machine. Next up is automation. It's really handy when your software just works everywhere, whether it's on developers' laptops or it's deployed to your Kubernetes cluster. You can use containers and configuration to ensure consistency. And then there's another use case which is kind of similar, but it's resource optimization. So sometimes the processes can be resource hungry and just like eat up as much as they want. Like, so it can eat up all the RAM, all the CPU, and then if you're running multiple processes, it can just like shut down everything else. So containerization, this kind of goes back to the isolation topic, but you can also use it to kind of constrain processes like, from a resource optimization standpoint, not necessarily an isolation standpoint, but kind of still is isolation. So next are my like specific reasons why I got exposed to different things here, like VMs and containers, and starting with VMs. So I worked at a web development company, and we had multiple servers, multiple clients, multiple developers, and sometimes a single machine would be more than what one client needed to actually run their website. So we'd have all like this rack of machines, and it's a question of how can we optimize and get most use out of all of those machines. And you can save some money by splitting them up. So we had also used it for development, so we could have like a live VM on the rack that had domains mapped to it and was just ready to go for like test development and stuff. So this is the kind of like first primary reason I got into this idea of, at least from a resource management perspective, containerization. So my much bigger one is compiler.com, which Ian mentioned earlier. We were a small startup focused on helping people code in the web browser. We made heavy use of containers for isolating user code, and the programs that they would write, we would actually run that all through our own servers and stream it up to the web browser, and had real-time communication between the two, and like collaborative editing, a bunch of different features. But I'll dive back more into this later, and I'm happy to answer any questions later on this too if you're curious about it, but I want to keep the talk mainly to containerization stuff and less about what we actually did. And so reason number 3, so a couple companies, well, the last 2 companies I worked at were Manifold was the most recent, was a local Halifax startup. And before that was LinkedIn.com. And in both cases, I worked with a team of developers. We use containers as a way to like consistently like develop and deploy software. Like I was using a Linux machine, other people were using Mac, but like because we were writing Docker files and using Docker, we were able to like have that software run consistently across people's devices for development. But like here at these companies, I also got some exposure to more like open source orchestration software, so Docker Swarm and Kubernetes. Docker Swarm was at LinkedIn, which I'll talk about later, and Kubernetes was at Manifold. Yeah, super great experiences, but yeah, we'll circle back. So those are some reasons why you might look at containers or want to use containers, or why I did. Let's get into compiler, because that's the biggest one for me. So being an online IDE, sorry, interactive development environment that supports multiple concurrent users had its challenges. Beneath all of the UI and UX components of it, we had to worry about file access and storage, sourcing software and libraries for use to compiler programs, real-time communication between the front end and back end, both in compilation and in running the software, and providing users with access to compilers as well as an execution environment for that code. So yeah, like I just said. Yeah. But that's where we use the containers, is in the building, like the compiling and running of the software in the cloud. And then we use WebSockets to stream it back. So the biggest challenge was that it was providing these users ready to use execution environments. We had hundreds of thousands of users signed up for the platform, and economics don't really work to give everybody like an active, like small instance on AWS EC2. We're a small startup. We didn't have that kind of cash to pump out hundreds of thousands of dollars a month on an internet bill or a server bill, I should say. So instead, we took advantage of the fact that only so many users were ever logged into the platform at once. And so programmatically, we could use the AWS APIs to add or remove capacity. And furthermore, users were generally working on smaller projects for school or to experiment with code on the go. And as a company, we kind of pivoted into an online learning platform later on, which kind of led to our acquisition from Lynda. But anyway, the small instances had more of AWS, their smallest instance had more processing power than we needed. But we had to stay clear of EC2 micro instances because at the time, the CPU availability guarantees were just horrible, and they would often lock up for a few seconds before responding. It's not like it is now where there's kind of like a baseline CPU availability, like they would just lock. So that's EC2 small instances were as kind of small as we could go. And this is back in 2011, 2012. So how to slice a VM. So we're left with these VMs, which are a little too big. We want to try and get the most out of them we can. So my first idea was to use VMs to split the AWS instances, but the AWS instances themselves, and for anybody who doesn't know AWS, that's Amazon Web Services, and EC2 is Elastic Compute Cloud. It's Elastic Compute Cloud. Yeah, the AWS instances themselves are VMs, and they weren't actually passing through the CPU virtualization capabilities up into the host. Like, so you can, in some environments, run VMs if you pass through the virtualization extensions of your CPU, but they're not doing it, or they weren't at the time on AWS, so I couldn't run VMs in the VMs. So my existing tool set wasn't enough at this point, so I started digging, and I remember reading about OpenVZ in the past and like kind of being familiar with web hosting and like running my own like personal servers for little things. So I knew there was a way that like people were kind of like doing this thing that wasn't really VMs. And so I looked more into that, and then that kind of led me towards LXC, which is the Linux Containers project, which I mentioned earlier, which is now like Canonical sponsored. But that was kind of where I started getting into this whole container thing. So here's just like a little graph of what I was thinking at the time in my head. So we had the bare metal, which is on the AWS end. We had the VMs. So the VMs were, the actual instances that I'm buying from AWS, the small instances. And then I was splitting it up with multiple containers on each instance, which, the users would access. So what makes a container? Back in 2011, there was still no Docker. The latest and greatest was Linux containers, LXC at that time. It was containerization software that leveraged Linux's newish control groups functionalities, also known as C groups, and which, when combined with the Unix tool chroot, short for change root, made pretty good containers. So let's get into that stuff. So chroot, change root, it's been around for a while in Unix operating systems. It allows you to run a new processor shell with an entirely different root OS directory, meaning different users, groups, limiting processes file access to the branches off that new root directory. Though there are technically ways to escape in certain situations, depending on what software is running and all that kind of stuff. But container security is an entirely different talk. This is just a rough overview of how containers work. So compiler used chroot change root to give users their own OS directory, very similar to what they'd see on a dedicated machine. So it was entirely free of other users' content. So C groups is a Linux kernel feature that adds additional configurable constraints to your processes. So you can limit CPU, memory, network, disk, and device access, similar to like all those constraints you put on a VM, if you're ever familiar with setting up VMs. For us, this was essential to ensuring that users couldn't starve out other users of CPU, memory, or break WebSocket communication back through the API by running like an infinite loop program. So you might be wondering what's with all this Linux stuff. I'm talking about Linux a lot. There is containerization for Windows within Windows, but if you're running things through Docker or most modern container software on Windows or Mac, you're most likely going to be running Linux or mainly like open source software through a subsystem. So this is all like containers for the most part, like 90% of the world, it's Linux. Or Linux on a Mac, Linux on Windows through like this lightweight kind of like emulation layer. So C groups can be used to contain constrain a process's access to system resources. chroot can be used to give that process a separate dedicated file system tree, but operating systems can be made up of many files and take up lots of space. So for us at compiler, like after a file system is used by one user, that file system would either need to be carefully sanitized or fully reconstructed, because we don't know what the user's doing to the file system, right? Like with their program or whatever, they could be like injecting, I don't know, some malicious thing that's going to steal somebody else's code or like shoot something off the internet. So we needed a solution, and luckily there is one, and it's kind of in union file systems and what's called copy on write layering. So copy on write, or COW for short, like COW, the acronym, is a core component of modern containers, just like C groups and chroot, or something very similar to chroot. So enter OverlayFS. So this was still in early development when I first looked at it. It wasn't fully merged into the Linux kernel until 2014, and this is still 2011, 2012. But like its predecessor, an AUFS, another union file system, which there were other ones before it. It allows you to have file systems layered on top of each other. So I experimented with this by having a read-only base operating system layer with writable layers on top of it. So when a file was read, if it didn't exist on the top layer, it would be read from the bottom read-only layer. If changes were made to that file, it would persist only on the top layer, with the full file being copied up. So this is like copy on write. So it's copied when it's written. It's copy on write. So the file is copy based on the write, but it's copying the entire file in this case because of the layered file system. So the problem, at least at the time with OverlayFS, is that it had issues with file locking. So sometimes it wouldn't fully release a lock, and I couldn't figure out how to get it to release the lock. And other times it seemingly would just not let me acquire a lock. And it was pretty annoying to debug, and I didn't have time to go deeper on the issue. So I was looking for alternatives. But OverlayFS as a solution is probably much better now. It's it's part of the Linux kernel was back in 2014, so which I think is version 3.18. But let's rewind a bit because for the next slide, I want you to think about data in different forms, not just like files on a file system. If you've ever heard of a disk image, it's a file that contains all the contents of a disk in binary form. So it's pretty common with people who burn DVDs or VCDs or whatever, or like make a backup of anything, because a disk image, like any disk, can have an image made of it, even a hard disk. And that disk image can contain a file system even, and that file system can contain an operating system. So enter the solution. So OverlayFS didn't work for me, but I kept digging around and found solutions with LVM2, which is Logical Volume Manager, which is another core component of open source or Linux operating systems. So LVM2 is just the version 2 of that. It had a big overhaul, but had this great feature called snapshots. And you could even create, so taking a snapshot of a volume, and then you could even create writable snapshots, so writable layers. So these snapshots use a binary form of copy on write. So it would copy up modified blocks of binary data. So like when you have like a hard disk or any disk for that matter, like the data is usually allocated in blocks. And the way LVM works with this is in terms of blocks. So it's not like on a bit level. I think blocks on average are maybe like 4 kilobytes or something. But it's been a while, so I might have that wrong. So yeah, this setup with LVM2 is much more reliable and easy to manage. I didn't have any issues with file locking. LVM2 is just concerned of a copy on write of this binary data. So having the file systems and layers bundled up and also having these file systems and layers being bundled up into single image files was much easier to copy or delete when switching between them. Because like these snapshots, when I'm talking about volumes and snapshots, I'm actually referring to files that I was using on a hard disk, not an actual hard disk. So kind of very virtualized disks. So here's a little drawing to help visualize the setup of this. So LVM has this concept of volume groups. So you add like these physical volumes is how they refer to them, but not necessarily always physical, but you add them to the volume group, and that provides storage capacity within the volume group, and then you allocate and create volumes within that volume group. So like the example on the left is my actual machine. So, you know, LVM is the all-encompassing thing. There's my root volume group, the actual hard disk is in there, and then that volume from that is output, which, you know, has its formatted in this certain file system format, and that gets mounted at as the root of my file system. So on the right-hand side is kind of what I was doing with LVM2. So we have my base OS image file, the copy on write snapshot file, which kind of goes on top, which is the write layer on top of the base image file, which is the read layer. The read layer contained all the base operating system files, and all the changes that the user made would actually get physically written to the copy on write snapshot file. So all this was combined into one layer on top. Next slide. So between C groups, the volumes of imaging, there was a lot to manage, but that pretty much sums up how containers work to compile. I can get into more of that later, but now we're going to talk about Docker. It came a bit late for me because we're already doing this other stuff, which I just explained, but let's talk about Docker for a little bit. So Docker wasn't always Docker. It actually came out of a hosting company called DocCloud, who, funny enough, I stumbled on when looking for smaller than like those small AWS instance sizes. They were using LXC a bit before I started and provided their users with like really small, cheap instance sizes for running their applications. Like you could get like 32 megabytes of RAM for like your PHP hosting. It was crazy how small they'd go, how small they were subdividing these machines. It was a neat idea, I guess, but it wasn't profitable enough for them. And they started realizing that maybe people couldn't actually benefit or could actually benefit more from like a suite of software, like the suite of software that they built to manage their containers. So I guess they had some chats with investors. They rebranded, raised a bunch of money as Docker. At the time, I was really jealous because I knew exactly what they were doing, and I saw how much money they were raising for it. So I just pre-launch, they had about 13 million, I think, from DocCloud or the transition, and then post-launch, they quickly gathered up another 45 million in 2014, up to over 300 million to date is kind of what is backing Docker. But yeah, maybe you'd be jealous too if you were in my position. So why it's good? I was still jealous and stubborn, and I want nothing to do with them when they launched. I thought it was cool, but I had built my own tech just fine, and I didn't want to take time switching and risk a whole new set of bugs and unknowns because they were still new. So I continued on my path, and meanwhile, they added a bunch of new functionality, more options for underlying containerization software, and eventually lightweight layers on top of Windows and Macs to run their Linux containers, because the previous way to run it was to actually use virtual machines on Windows or Mac to run Linux, which then ran Docker. And they had like a little agent that communicated between everything. They actually, the newer versions, they pumped out actual like lightweight virtualization layers that will just run like the Docker kind of like Linux container hosty thing on your machine. But at the heart of all of this was the Docker Hub, which is an easy way to publish and share software images and see what images they're based off of. It was like GitHub. It was the GitHub that like the container movement needed to kind of like break out and become popular. So every popular like OS distro and piece of hosting software had an image. Like you could just go and like install it or base your image off of that image. So this is all further backed by their Docker file scripting system. At the top of that, you put from, and so from is whatever image you're pulling from. So it could be like whatever, like Linux distro, or like even like somebody else's software bundle, which would have, and then somewhere in the chain inherited from another Linux distro. So it really brought containerization to the mainstream. But it's a sad reality that so much of this open source software that builds this stuff is kind of like lost in the unknown or complexity. But yeah, by building out a solid foundation for everybody and a sharing platform, I think they really kind of hit it out of the park. So yeah, Docker is a hot topic, but it's not perfect. Like they do have some issues. There are like workarounds and stuff, but there are also other container like solutions with entirely different like approaches to running containers. So I recommend also checking out Containerd for Windows or Linux users, or just use the built-in system VM spawn on Linux. But yeah, if you're on Mac and you want to use any of this other stuff, you kind of have to use like a virtual machine to test it out. So quickly, I know I'm a little bit over, but this is going to be like 5 minutes to run through. I just wanted to touch on orchestration really quickly. Yeah, so when I say orchestration, I mean deployment and orchestration with containers. So I'm going to go quickly over what I did at compiler and hopefully move along to Kubernetes. And yeah, I convince you that's just the right thing to look at. So anyway, autoscaling at compiler, we didn't really have, like us as a company didn't have autoscaling back in 2014. We could only handle around 100 concurrent users at peak with the architecture we had built. And then we were acquired by lynda.com that year. So part of what we had to build for them was a way to expand and contract capacity further so we could match the user base. We came up with this idea called these monitor controller machines that would oversee a pool of what we called run servers, which were machines where the containers ran. So the monitor servers would respond to demands seen in the API and preemptively spin up servers to handle more potential burst, and then wind down servers in idle time to save money. So here's a old drawing of the, here with the happy user up here. The files stored on S3. Here's the API, the servers over here, the run servers, they got containers and there's whatever. And this is all within an availability zone. So the idea is that you would deploy to multiple availability zones, and it's, handles more users than lynda.com would ever have. But anyway, lynda.com got acquired by LinkedIn in 2015. So we had built out our thing for lynda.com. It worked for lynda.com. But LinkedIn was a whole new system, wanted a whole new system because they're building this whole new LinkedIn learning platform. The idea of containers was also pretty scary to them. They're like a Java shop. They're used to operating a certain way. But we managed to compromise by using Docker, which, at this time, it's now 2015. Docker's out. It's gaining traction. People, especially in California, know about it. So it has more trust. So we started to build up a new system. Using Docker Swarm was very similar to what we had set up with the monitors and the run servers. You can see here that the diagram looks similar. You have the managers and they have workers, and then the containers run in them. But it's much more general purpose, which is pretty neat. So we managed to build similar container images to what we had at compiler when we got the whole system running in a year, despite bureaucratic process and rewriting all of our controller software in Java. So it was pretty good. But yeah, anyway, Docker Swarm, it's decent, but Kubernetes is so much more, so much better. So my own experience is somewhat minimal actually using Kubernetes, though I do know a lot about it. I have used it. I just haven't deployed a lot with it. So it has so many configuration options, a great API, and even job scheduling system for queuing containers. It can mostly, in my opinion, replace a cloud provider system like AWS EC2. Like if you're really used to scripting like EC2 and setting up a lot of constraints within EC2, it can replace a huge part of what these cloud providers offer kind of as a baseline. So as long as your software is built and published with containers in mind, could be a good solution for you. So in this diagram, you can see how, this is from Kubernetes, you can see how this kind of like relates to the previous ones. They have these nodes over on the side that nodes actually run what are called pods, which are your containers, and over on the left is the control plane, which is much more complicated. Like it's an entire suite of components that work together to manage the cluster in different ways. But if you're a company where deployments have some real challenges and you're not using Kubernetes, I suggest checking it out. And if you don't use it, maybe you'll at least find some inspiration. And thanks for listening. And special thanks to my brother Robbie for giving me some ideas and helping me with the slides. And yeah, I hope you all learned something, or at least found something you could dive into, like something you could dive into to learn more about, or like I've at least got you interested in something. Yeah. Questions?
Awesome. Thanks so much, Tim. So I've allowed people to unmute. So as long as it's not crazy, you can leave your question in the chat and they'll get asked to Tim, or you can just unmute and pop on your video and ask away. We're gonna just let it be whatever in terms of who goes first. So if you have a question, feel free to ask. So there's a question in the chat about Knative, Tim, and your thoughts on Knative.
Yeah. I don't personally have any thoughts on Knative. I'm not like super familiar with Kubernetes. Yelmer was talking to me about Knative before, but that was like 2 or 3 years ago. So I don't have any thoughts about Knative, but yeah, Yelmer, yeah, thanks Yelmer. Yeah, Docker is pretty cool. Definitely check that out if you haven't. Yeah, and then if you want more, check out Kubernetes. It's kind of like the path to take, I think, in the modern world, rather than like looking at something like LXC. Docker has a lot of resources too on just like learning about containers and like even how they built Docker. Like they have a lot of documentation. Yeah, just to kind of like explain how the whole thing works, because like when you are running it, you are running a lot of software on your machine, so they do have an obligation to explain it to you. And it's all there on their website and their docs. So it's a great resource to kind of start like looking at this stuff too and learning more about containers yourself. And Yelmer says, don't forget about Nomad. I don't know Nomad. That's probably another container thing. That sounds familiar.
Nomad is the HashiCorp Kubernetes alternative. Is a way to frame it.
Oh, yes.
Yeah.
Oh, okay, yeah, you should probably look at that one before Kubernetes. Just because I have some friends who worked at HashiCorp.
That's a terrible plug. Shameless plug. Shameless plug.
It's better to be transparent about it rather than hide it from everybody. But, I mean, HashiCorp has done a lot though, like HashiCorp Vault and like Terraform's theirs, isn't it? Yeah. So yeah, HashiCorp is huge. Definitely take a look at HashiCorp's products. Like they have a lot of great stuff for like orchestration, not just container orchestration.
I see there's a question from Jonathan Seller regarding what was the news about K8 dropping Docker support last year? Is it Docker syntax actual files?
So they're switching to container D.
Yeah.
Yeah. So containerd is what to look at. Containerd is trying to like replace Docker as the more open, I don't know, maybe corporate, googly friendly kind of version of Docker. But yeah, they have like a native Windows runtime and Linux runtime, I think, for containers, and yeah, a lot of support for Docker stuff. Yeah.
I believe there's a question about M1 Max.
I do not use the Mac. I will defer to somebody.
I believe the answer, the complex answer is yes. Well, the simple answer is yes, it works. The complex answer is not in the way that you want it to. It's not 100% working today. I think there's a virtualization layer they're building underneath it, but you can get Docker to work on an ARM-based Mac, but you will not be running. It'll be running through a virtualization layer because your containers compiled for x86, and then it virtualizes it to ARM.
I think there are like, if it's not Docker, like somebody does have ARM builds of like container software, at least in the Linux sphere. So, and yeah, it's just for Macs and Docker specifically. That's a question in that emulation layer. Like, did they cover all their bases?